Lecture 25, Load Testing. At this point, we've had an extensive look at the subject of observation. That is to say, identifying areas in the execution of our program that are a potential issue, or at least we think might be a potential issue. So now we've got to take what we've talked about and relate performance and scalability. Very early on in the course, we mentioned that one of the goals is a discussion around how to take software from 1 user to 100 to 10 million, or more if we need, right? And that is where we're going. To get there, we probably need to do some profiling to try to find out what is slow. We need to make some decisions at that stage about what to change, but we also have to think about what is our current maximum number of users, or what's the maximum transactions per hour or per day, or something to that effect, right? As Billy Idol says, in the midnight hour, she cries more, more, more. Rebel Yell, great song, fully recommend it. Okay, but this is not a hypothetical situation, right? A few years ago, I was asked a question by a chief financial officer as to whether the particular system under discussion could handle 10 times as many users as we have now. And listen, she's a chief financial officer. She wants numbers. I can't just say, oh yeah, it will be fine, trust me. That's not going to fly. I have to be able to support this answer with some analysis and with some figures, right? So how do I do that? Well, I have to look at the data we have and maybe have to set up a test to actually evaluate and see what happens, right? So that is ultimately load testing. Now, start with why. Why are we doing this, right? If the CFO says, I want to know how many users this can handle, that's one of the 5 options that appears in this list, but it's by no means the only one, and it might not even be the most important one, depending on your use case. So let's go through a few possible answers. So one is before a new system is built. This is an analysis that takes place in advance, and management wants to know what are the limits and the risks. What is the design load for this system, or how do we estimate what it's going to be? And this gives us some upfront information about whether it's going to work. Is it going to meet our needs? Is it going to be sufficient for the purposes of the company? The second one in the list looks like the CFO asking me, can the system handle it? That is to say, there is a predicted workload increase. Whether or not the workload increase actually happens is out of our hands at this point, right? That's on the sales team to deliver. But hypothetically, if it did happen, could we handle it, right? That's a very important question. Number 3 on the list is a sudden spike in workload is expected, and in this case I'm thinking tax season, right? If you make software that does tax filing, right, and in Canada the due date is April 30th, and you need to submit your taxes on or before that date to not have to pay late penalties if you owe money, right? That sort of thing. It puts a big spike in the workload. That's a little bit different from the previous one. The previous item is more about, okay, if there's an increase in the steady state workload, instead of 10,000 users using the product every day, there are 20,000 using it year round. But the sudden spike in the workload is more it is April 29th and everyone is in a panic, and so 50 times as many users as usual are trying to use the software right now. Can we handle it? Reason 4, the system has a high uptime requirement, 99.99% or something. More nines cost more money, that's for sure. So we have to be sure that it works over an extended period of time. And the last reason is, it's included here for completeness, but it's not a real reason. But call me cynical if you will, but the project plan has a checkbox that's labeled performance testing, even though nobody knows what it actually means. Okay, so if we leave aside that last one, right, each of the actual reasons gives you some understanding of why it is happening and what kind of testing should take place. So if it's a new system, maybe we need to understand the average workload, plus perhaps a buffer for safety, and make a plan for that. If the workload is expected to increase, 10 times as many users, we need to establish our bottlenecks, as in the next topic, to try to identify what we think the limit is. If it's the spike situation, then we need to try to find a way to simulate that, generate spike behavior to see the system's response, and perhaps the hardest part is creating the test. Right? And finally, if our reason is uptime requirements, in addition to putting a lot of load on the system, we have to maintain it for an extended period to make sure there's no performance degradation, a test of endurance, if you will. Right? So what's our average workload? What's our bottleneck? How do we simulate a spike in workload? And what is the endurance? Okay, so load testing is not exactly the same thing as stress testing. And if you've watched Bar Rescue, then you'll be familiar that John Taffer wants to try to find out what goes wrong by bringing in a lot of customers to bars that are badly organized and don't have good systems and perhaps don't have the right employees in the roles for the jobs. Load testing is not the same thing as stress testing. Your intention is not to turn up the pressure until things break, or at least stop working well. We're not really going to talk about stress testing in this, but you can apply load testing strategies turned up to the max to get stress test results, right? Like a key distinction is if the CFO wants to know, can it handle 10 times as many users? I only need to do a simulation that says, can it handle 10 times as many users, yes or no? And once I have an answer to that, I'm done. I don't have to go the extra step and be like, well, it turns out 22.9 times as many users is the most that we could handle. That second one would be a stress test. You don't have to do it. We can skip that. We can stop when we've accomplished our objective. Okay, so maybe you've heard the saying that plans are useless, but planning is essential, right? And this comes from the idea that, like, whatever plan you make, things are probably not going to go according to plan, and that's fine. But the idea behind planning is, like, we invested effort into understanding what there is to do and how we're going to do it, and all of that is useful for giving us knowledge about what is supposed to happen when the plan inevitably goes off the rails. Okay, so important questions are who, what, where, when, and why. If that sort of sounds like elementary school kind of thinking, sure. We just covered the why question, and we also understood how that tells us about what we're going to do. So if it's uptime requirements, then we're interested in endurance. We have a why, and we have a what. So that leaves who and when. In a company or working on your FYDP kind of situation, yes, there might be an opportunity for debate or discussion about who should do the tests and when they will take place, and that's probably a reasonable conversation to have. But for the purposes of this course, right, it's we are going to do them and we're going to do it now. So we can skip sort of all of the rest of that discussion. Now, in real life, though, you probably do need to make a plan, but how detailed the plan is going to be depends on the needs of your organization, and the same applies to how many sign-offs, if any, you need for the actual plan. Right? Some companies, just by their nature, have a high need for justification of the time invested because time is money, developer salary, and opportunity costs. What work are we not doing in favor of this? There's lots of literature out there about how to justify technical investments to senior management. It's a subject I'm passionate about, but let's not get sidetracked, right? Technical investments are important, even if they are sometimes hard to quantify. Okay, but let's not worry too much about the sign-off for now. The most basic plan needs at least a definition of what will be tested, how it will be tested, and how do we know if the test passes or fails, right? So a simple scenario looks something like we'll test saving things to the database by generating 10,000 update account requests. We will submit them all at once, and the total time to complete all transactions should not exceed 15 seconds. Okay, that covered each of those things, what we're going to do, how we're going to do it, and how do we know whether we succeeded or failed. That's all made up and probably even a little bit silly, but listen, we hit all 3 points, so there we go. Okay, so what workflows are we going to test if we want to run some sort of system test? And like, yes, hypothetically, right, in a very simple microservice that does exactly one thing, well, you can test exhaustively, right? But in a more complicated system, you may have a clear direction about what to do, but we don't have the time to test everything, right? Aiming for 100% coverage is unnecessary, and load testing should be reserved for where it's truly needed, just because it has very high cost and very high effort requirements, right? You may be able to argue for doing a lot more unit testing and getting closer to 100% test coverage, right? But we're trying to get to the minimal amount of load testing, just because it is expensive. So if we already know what workflows or functionality is slow or rate limiting, or what's on the critical path, that's great. We can start there. We don't have to do any deep investigation, at least at the first plan, because we'll start with those things that we've already identified. Maybe you need to add observability first to identify those things, or if monitoring doesn't exist, how do we know, right? Like we're not sure what it's going to be. So adding observability and then finding out will be helpful. Now, if we're talking about a new system, like that is to say there exists no implementation for it, or perhaps the implementation is partial and not working, what are the critical workflows? I'm new here, how do I know, right? So critical is determined by the nature of the product and what you want it to do. So there's 3 suggestions on the board there for what you might use to decide whether or not a workflow is important enough to pay attention to it in load testing. Just because it meets one of these criteria doesn't mean you have to choose it, and just because it's not one of these 3 things doesn't mean it's not critical, but these are my suggestions for places to look. So the first one is anything that is computationally intensive work. Right? If this is going to take a lot of effort, you're going to spend a lot of time, CPU time that is, doing the thing, right? There is a potential that your CPU is a limiting factor, and we need to know, right? Compile analytical data takes a lot of CPU time, takes a lot of effort. Good. This is a great thing to do some load testing on. Option 2 here, or item 2, is about user experience, and that's much more common in things that are not as computationally intensive, but matter much more for user workflow, right? If we have information that says users quit the sign-up process for your application if the sign-up page takes more than 2 seconds to load, then we care a lot about making sure the sign-up time doesn't exceed that limit, no matter how busy the system is. Right? And there can also be external requirements that require load testing. If you are processing a transaction and you have to return from your system a yes or no answer within a certain period of time, let's say 1 second, anything that's part of coming up with that answer is on this critical path, and it is worth testing, right? Because we want to validate that we can always return an answer before time runs out. Makes sense. Okay. So those are sort of good suggestions for what to do, at least to get started for a new system. If your current utilization, though, is low, you have an existing system, but we're not sure what it is, right? It might not be clear immediately what the bottlenecks are. And that's fine. You can take a guess, but you should be prepared to revise those guesses partway through as you ramp up the load. In fact, you might need to do that even if utilization is high, because it might turn out that what you thought was the limiting factor isn't anymore. So if it's uptime requirements, though, we need to talk about endurance tests, and we're going to talk about endurance tests in a little bit. We'll come back to it. So how do we test them, right? Given the workflow and the kind of tests that we want to do, we need to think about what tools and what hardware do we need, right? So carrying out these tests might require provisioning additional hardware, virtual or otherwise, particularly if they are long-running tests. Regular CI/CD type tools, test harness might not be suitable because it's intended for unit tests. You might need custom tools or different ones or something like that, right? But you might need to allocate another virtual resource to execute the test because it's going to run for 60 hours or whatever it is. That's fine, right? If you want to run these tests to evaluate or experiment, or if you have an application developed, we need to think about the differences, though, between dev and production systems, because it's not super convincing if I say, well, it runs fine on my laptop, right? So I'm sure that we can meet the goals because I ran it on my laptop and everything's fine. But that might not be true. So one possibility is simply test in production, which I don't recommend. But we want to test in something that's as production-like as we can manage, right? And it is important to think about how scalability testing is not the same thing as QA testing, right? You might do QA on your local computer before you push the changes into a pull request and it runs on your continuous integration system. That's fine. It doesn't test scalability, right? You want to know, did the tests pass, and you wanted to know, did the tests pass before you reach the timeout in your test runner. That's not the same thing as scalability, right? And testing on production-like machines is important, right? Low-end systems can often have very different limiting factors. Your laptop might have 16 gigabytes of RAM, and that might be a limiting factor in the execution of the application, but the production server has 128 gigabytes of RAM, so RAM isn't an issue. And if you didn't pay attention to this difference, you might spend a lot of time trying to optimize for memory usage, even though it doesn't actually make any real difference once you get it into the production system, because there's more than enough memory there. But things can go the other way as well. You can run it on, here's the newest, latest, greatest dev laptop with everything set to max. And that's not actually the kind of instances that are provisioned for running your application. So you might end up with results that look really good on your machine, but are actually not that good when they're running on the production server, because the production servers, for cost reasons or otherwise, are just not as powerful as that. Then there is the reality principle, and it's good as much as you can to use a real workload if that can be done. Right, this joke here about a QA engineer walks into a bar, orders a beer, orders 0 beers, orders a whole bunch of 9 beers, orders a lizard, orders -1 beers, orders some junk keyboard mess, right? Like those things are foreseeable, but the first real customer walks in and asks where the bathroom is, and it says the bar bursts into flames, killing everyone, but you might say application crashes is the less dramatic version of this. Right? Why did that happen? Well, because QA engineers, think like the developers of the system, and their idea of what people might ask or what unexpected inputs they might suggest are not necessarily what would be used in real life. Okay, right? But what I mean here is about using a real workload, and probably for legal reasons, you can't just take a copy of the live production database and use that for testing, but you want to try to simulate it as much as you possibly can, right? If you have limited test scenarios or limited data, you will get inaccurate test results. Right? If you might say 1% of your customers use the annual subscription, but actually the real data says 10% of customers are on annual subscription, it might make a difference in how long it takes to run an analysis. And your test database might contain 500 users because that's the default test database, whereas the production database contains 50,000 users. But that can go the other way. I've seen a situation where actually the test data had way more customers, because your tests create and don't delete entities in the test system database every time they run. They're just randomly generated customer IDs, so there's no collision problem. But it means that actually running it in the test system takes longer than in production. Similarly, this can result in things like I was an incident responder one time on an incident where an app doesn't start up because the database migration takes too long and it's considered stuck and gets killed. And this wasn't caught because the size of data was smaller, and so deployed successfully to the staging system and then failed when deploying to production. Oops. Another thing is that user behavior is hard to simulate. If you are writing, here's a thread that executes steps that we imagine to be the user, users don't always behave like we would model them to. Another scenario that I can talk about from past experience was that you might assume that company managers run the month-end report, once, maybe twice, once the month is over, but your users might choose to run them every hour. The manager was using a report to keep an eye on what his team members were doing all day. Seeing all the figures change from time to time gave him an indication of what was happening. Now listen, you would be correct in saying this pointed to a deficiency in the product design, that there was something missing there, and there's a feature we could deliver that would be much less computationally intensive to let him have an idea of what work got done. But that's not the situation we were in, right? The user's actual observed behavior didn't match our predictive model. And then there's the volume principle. And the volume principle says more is the new more. It's okay to use light workloads for regression testing, but if you want to see how your system performs under pressure, you have to actually put it under pressure, right? You can simulate pressure to some approximation by limiting the amount of available RAM, run it on an instance that has limited memory available, or run something very CPU intensive at the same time, but it's not actually the same as having a really high workload. Why is that? Well, the reason is not so much the test as what you're not seeing, right? If I want to test the app on my laptop under CPU pressure, I can run it while I repeatedly convert lecture videos to the YouTube format to just consume CPU cycles. And it does have the effect of limited CPU time available, and I can see how the app performs when CPU time is maxed out, but that's not actually the same thing as having 500 concurrent users, because you might not get to full CPU usage due to other reasons, lock contention, something like that, right? So this volume principle is what's of great interest to customers who want to know, I have 5,000 users, will your system be able to support me? Or to C-levels who want to know, can we deliver promised levels of performance or throughput, or what the current maximum is. Okay, and then there's a need for reproducibility. Rule 1 of science is that results need to be reproducible. That is, 2 different runs of your load testing of the same code should produce results that are similar. There is always a potential for a little bit of variation. Unit tests expect results to be the same every time, but load testing often has a larger degree of randomness and variation during runs, just because of the natural randomness of the operating system, the nature of the workload. Randomly generate 10,000 customers who have random data and random profiles, and scheduler luck and so on can definitely mess with that. So those are the key principles for actually executing those tests. And then there is the question of endurance. And I said we would come back to this, so here we are. And you're probably familiar with the idea that endurance is different from peak workload, if you will. So here's a good example, talking about running for, exercise and health, allegedly. Can I run at 10 kilometers an hour for 1 minute? Yes, of course. In fact, for a 1 minute sprint, I can run much faster than 10 kilometers an hour. Fine. Can I run at 10 kilometers an hour for 30 minutes? That is, do a 5K run in 30 minutes? Yes, I can. Could I do that for 10 kilometers, right? 60 minutes? Yes, but with some difficulty. I don't typically run more than about 5 or 6K, and could I do 10 kilometers if I really wanted to invest the effort? Sure, but could I do it for 4 hours, 40 kilometers, which is not quite a marathon? The answer is no, right? We found some sort of limit. I can endure an hour at this workload, but things kind of break down after that. Once I'm past 60 minutes or something, I will get tired, and either I will slow down, I will stop, or I will just hurt myself, right? You shouldn't wake up one day and say to myself, I'm going to run 3 times farther than I've run in the last 3 years. That's not a genius plan, right? But we found a limit, and if you studied my running for a period that's less than half an hour, you might conclude that I could run at 10 kilometers an hour forever, or at least indefinitely, right, for an arbitrary amount of time, even though that's absolutely not true. And our sample period is too short, right? This is incidentally a common fallacy in the media. If you look for this, you'll find a lot of news articles written by journalists where they write something that's like, the current situation will go on forever, even though, yeah, that's rare, right? Things change all the time. There's, political parties win an election, they're often voted out again after a few years. If the job market is bad, it may improve. If the job market is good, it can get worse. Interest rates can go up and then they can go down. New and unprecedented things happen a lot. Change is constant. So it's really important that you're looking at a reasonable sample period to make a decision about whether this trend is enough or if it's going to continue. So things do change all the time, right? And the problem that we face here is that, like, if you just observe my running for 15 minutes, we don't have a long enough sample size because it doesn't reflect what I would describe as sort of the cumulative negative effects, right? Like, as I'm running and I'm building up lactic acid in my muscles and I'm getting more tired and using up energy, and my muscles are getting sore, right? So there's like cumulative negative effects that eventually build up and make me slow down, and at some point I have to stop. All right, you might also argue that one of the cumulative fatigue factors is I might just get bored. But okay, does this matter, right? If Tetris has taught me anything, it's errors pile up and accomplishments disappear. That's kind of overtly negative, but okay. Listen, you might say this isn't a good analogy because CPUs don't get tired, right? You know what Kyle Reese says. The Terminator's out there. It can't be bargained with. It can't be reasoned with. It doesn't feel pity or remorse or fear, and it absolutely will not stop ever until you are dead. So CPUs don't get tired, nor do their parts accumulate fatigue at the same rate as a runner's muscles, right? Like, yes, eventually, a GPU breaks down or whatever because of heat damage and stuff like that, but not on like a 30-minute time frame or not on a one-day time frame, unless you're doing something really wrong, right? But it's still a valid analogy. At least I'm going to argue that. A process that has a data hoarding problem is slowly accumulating memory usage, and when its memory space is exhausted, you might encounter a hard stop, like you get a java.lang.outofmemory error Java heap space kind of thing, or you just get a degradation of performance based on the increasing amount of swapping memory to disk that is required. And the same applies if you're filling up the disk, exhausting file handles, log length is too big, accumulated errors, whatever it is. All of that is a little bit like fatigue for the executing application, whether it's building in the program or building in its environment, right? It builds up over time, and eventually its effects force a slowdown or stoppage of execution, right? Accumulated fatigue for an application is also not just a hypothetical. I've personally seen services that encountered a problem due to running out of internal resources as a result of a holiday season code freeze. It was late December, right? And everybody said, okay, we're going to freeze changes to the code base over this period so we don't have any incidents as a result of newly introduced things. And, well, it wasn't a load test in the sense of applying a higher load, but it was a surprise endurance test. Right? The solution to getting the error rate just involved restarting the instances one by one, and things got back on track. Right? This problem had never come up before, simply because during the normal week the application would be restarted for new code deploy or something like that on a periodic basis, so it wasn't likely to stay uninterrupted for a period of a couple of weeks. And yet, right? Turns out that was a problem. Right, and this was not a high load kind of endurance test, right? It was a fairly low load endurance test, but it was still valid. Okay, so how do you choose how long the observation period is, right? I've said in the running analogy, like 15 minutes is too short. Is 30 minutes the right running length to get a real idea of what I can do? Should it be 3 hours? I don't know. Once again, our first guide might be product requirements for what we're building and testing, right? If it's an e-commerce platform, then the endurance test might be something like 5-day period that covers US Thanksgiving, Black Friday, and then Cyber Monday. Maybe you choose the maintenance window for the program. If maintenance window is designated, Sundays from 2 to 3 a.m., and there can be downtime during that period according to the contracts and service level agreements that the company has signed, well then you want to validate that the system will work correctly and consistently long enough that it can be restarted or only updated during that maintenance window. You might be able to buy yourself some time with like rolling deployments that are non-disruptive, right? But if you want to know, can it go the 167 hours without a reboot, that's a reasonable period of time to evaluate. Unfortunately, though, there's no universal rule that we could offer that would give you the exact amount of time to evaluate. You'll just have to consider the requirements, the likely scenarios, and use your judgment. Okay, so how do you evaluate success? There's two kind of answers to what load testing can give you, and they're kind of related. The first is yes or no. Can the system handle a load of X? The second is, what is the maximum load Y that our current system can handle? Now, answering question 2 is difficult, but sometimes question 1 is really all we need, right? Like if we know the answer to Y, then, well, if we just compare X to Y, we can say yes or no fairly easily. If the maximum number of users is 500,000 and the question is, can it handle 25,000? We can say yes, absolutely, right? That sounds like Y is better and we should always try to find it, right? But it may be more difficult, right? The difficulty of generating test data or generating simulated load might increase much faster than the rate of load being added to the system, and we might be crossing over into stress testing, right? Like the complexity of, okay, we're going to write 50,000 threads that simulate 50,000 concurrent users, right? The difficulty of simulating more users might exceed the workload that's being put on the system, so maybe that's not actually that helpful, right? There is also a bit of nuance when we talk about what is the maximum load of Y. Is that a hard stop? Like if we reach that limit, then we crash, we run out of memory, we start rejecting requests, or maybe it's just a degradation that like beyond this point, performance is below our target or below the minimum that we consider acceptable. Because there's probably some range that the system can handle perfectly well, and then there's sort of an ongoing declining ramp that says, all right, it's getting worse and worse as load increases, and at some threshold we say it's below the acceptable minimum. Okay. Now, we may need to add some observability to existing code to help us decide here whether a test passes, right? Logging that tracks events from start to end, gather the data that we need to make the overall make the overall decision. Examples that we're looking for are like, is the total work completed within the time limit? Do items get completed within the item time limit 99% or more of the time? This might result in just writing a bunch of stuff to log files, and then you have to do some amount of post-processing later to aggregate and analyze the data. And hopefully there's not like too much manual work that needs to take place to correlate the data, but it could happen, right? We'll see. Correlating it might be like, oh, can you correlate this with some other external known factor? But hopefully at the end of that you can look at an outcome and you can say yes or no, the scenario passes or fails. And another thing to note is that in an endurance test, it's not really whether the system could handle X load, but it's about whether the answer continued to be yes consistently across a long period of time. Right? So it's not just, okay, well, it passed at the beginning and it passed at the end. How did it do all the way along? Right? And what does the trend look like? It may have passed, it was fine from start to finish, but in the beginning it was doing very well, and near the end it was close to the limit in terms of what we consider acceptable. That trend might actually be interesting. Okay, so suppose you've failed the load test, right? Like the software program, when it comes to running, I can get better, right? I just need to make some changes. How do I do that? Well, I've got to change what I'm doing. I need to practice, and hopefully I'll improve, right? Maybe I need to practice running faster for a bit. Maybe I need to increase slowly. the running distances. Maybe I need to go for more runs each week, something like that. As the internet might say, get good, or get good. Okay, so if the program fails, right, there's probably one or more specific scenarios that we can improve, and we can apply techniques and technologies from this course or elsewhere to make that part better. And we can rerun the tests, and we can reevaluate, and if all is well, we're done. Repeat as necessary until we've passed the scenario. But listen, there's also a point at which I can make no more improvements in my running. Eliud Kipchoge ran a marathon in 2 hours, 1 minute, and 9 seconds, which at least at the time that I was writing this was the world record marathon speed. That results in average speed of, 21.02 kilometers an hour or something like that. There is absolutely no chance that I am going to be able to run as fast as this, no matter how hard I train, right? Like, this person is a world record holder. They clearly are, the best in the world, at least at the present moment, at being able to run, and I'm not going to catch up to him, right? I'm just not. No matter how much I train, I'm not getting selected for the Canadian Olympic team, at least not in distance running. And the same is true for our program, right? Like, as much as we might like to think, yeah, we can always sort of redo the thing, right? We can always retry, make some changes, rerun the scenario. We might not ever get it to this level. And that's okay, right? That's not the end of the world. Maybe the software we have is not the right one, so that might mean we need to redesign or replace it. That can happen. Another idea is change expectations, right? What if I said I could run a marathon? Can I run a 4-hour marathon? Like, sure, I'll have to increase speed a bit from 10 kilometers an hour, but it's not impossible, right? I just have to have reasonable expectations. If it's, for example, unreasonable to bill all of your customers, on the same day, say on the first of the month, can you convince management that what if we spread out billing across the rest of the month? Right? It's not a totally insane idea. Other big companies do this. My phone bill is due on, I think, the 4th of the month. So, like, that's possible, right? If you can make a good argument, you can convince people that actually we just changed the requirements a bit, and then we don't have to bill everybody on the same day, and we don't have to do as much work in a single day. Now we have, at least 28 days in the month, which really helps. So, yeah, think outside the constraints, i.e. the ones that are given in the initial problem statement, and you may come up with a creative solution that isn't exactly like, let's make the software faster, but it does solve the problem, which is, will we be able to collect payments from X amount of customers this month? You may have heard the saying, constant vigilance, around the subject of defense against the dark arts, right? Load testing at a given time captures the state of things at that time only. And it needs to be repeated regularly to catch performance degradations that would make your software fail to meet its targets or design load. Those are rarely intentional, but it does take meaningful effort to stay on top of it, right? Like, as software grows, people want it to do more things. We added this new scheduling option, or we added this new option for letting people do this, or adding this new feature, or now we support 2 different integrations. All of those things add complexity and increase the risk that things get slower, right? Over time, hardware does get better, and it can offset some of the slowdown of the added complexity. But at the time of writing, this is an era of small incremental improvements year to year, not big leaps and bounds forward. But if you remember my previous aside about how the journalists always say the current situation will go on forever, obviously I'm going to say let's not fall into that trap. I don't want to say there will never be revolutionary change in execution hardware that offsets these increases in complexity. There was a period of time, 1980s and 1990s, where like CPU throughput was increasing at a pretty rapid rate, and it made a lot of like load testing and performance optimizations kind of irrelevant because the CPU was getting so much better. It's like, we just wait, and next year CPU will have double the clock speed, and we'll just recommend people buy that. I don't know that era or an era like it will return, but I'm also not going to fall into the trap of saying that would never happen, because I honestly don't know, right? But for now, we're in this era where it's small incremental improvements in terms of execution hardware. You do get improvements from time to time, a new generation of whatever comes out, and it can make a big difference, but it's not, it's 10 times better than it was. So for now, we have to repeat the load tests relatively often to make sure we catch major regressions before they become a problem, and in particular before they become like major releases that everybody is banking on now, right? Like, it's really hard to walk back a feature once it's in the hands of customers. It's really hard to say like, oh yeah, we added this live real-time reporting, but it actually makes the whole system really slow, so we pulled it out again, right? You want to try to notice that and do something about it before you have to take away something to which users have become accustomed. So there's a real life example. The website arewefastYet.com tracks regressions and improvements in Firefox performance, and it is something that they watch for, right? There are situations in which a regression is expected because we are doing more work, but it is something to be mindful of. So this gives us an introduction to the idea of load testing. It is a complicated subject. I don't think it's something where there's like a tool or product that has it all figured out, but it is interesting, and it is something that we need to do quite often in real production systems.